right, good morning, good afternoon, whenever you are looking at this. We are going to deal with this Quiz 2 preview here in Unit 1, some absolute value and some graphing. Let's get down to business. Okay, first things first. When you're looking at this first one here, actually the first 5, this entire page, when you're dealing with absolute value, you have to have 2 equations, 2 inequalities. Otherwise, you only have half the work. So, when doing this, my first job, just copy the first one I see. I lose the absolute value bars, but everything else stays the same. When I get to the second one, the only thing that's going to change is the sign on my answer half is going to change to negative. Everything else is the same, and now we just have to solve the 2 equations that are here, our 2 steppers, and we're good to go. So again, it's all about isolating my variable term. So we got that boxed in. We're going to do the opposite of minusing 3 here. And we're going to divide by 6. As I always tell people when I'm making these and I'm not live in class, if I tend to go a little speedy, you have control of me. So you can pause me whenever you want, unlike when I'm in class. So take advantage of the situation, pause me, rewind me. Heck, you can even mute me if you want to. Wouldn't do you much good though, I don't think. But just gotta keep telling yourself it's about opposites. We get to the end, we're good. Okay? Nothing really different with number 2. Okay, I always check first again to make sure my absolute value is isolated by itself. If there was a plus or a minus outside, or let's say a multiply number, I'd have to undo that first before I split it into 2. So just keep that in mind moving ahead. I might be giving a hint, I might not. We'll see. And some of you out there may be wondering at this point, well, wait a minute, I thought absolute value always was positive. Why is that still negative? Or why didn't I turn that into plus? Your solutions, okay, when you plug in numbers here and then take the answer out, yes, that would be positive. But for our purposes, if we want to get the actual answers that are going to work for this, to make this true, we've got to leave the stuff in the absolute value alone. So I just keep working my way through, watching my signs, not losing negatives or something in some place, because that's the easiest way to lose partial points. We don't want to lose partial points. We want them all. And so as I'm working through this, okay, 2-step equations, that's all it basically is I'm working through those. So equations, okay, that's not too bad. When we get to inequalities, the rules in general are going to be the same, but we've got a couple extra pieces to play with here. And I'm going to add one piece to this part. We're going to do interval notation too, just because I think it's a good thing to have working ahead. So here I'm going to try and use more color so we can tell the difference between things. Still need to have our absolute value isolated, and it is. So as we did before, first one, just copied. Second one, copy everything until you get to the arrow. Once you get to the inequality arrow, we're going to take its inverse, we're going to flip it, and we're going to change the sign of the answer, just like we did when we were working on the equations up above. Still going to just solve these normal. Want to get m alone, do my opposite. Make sure your arrow doesn't switch. Make sure you keep your variable on the same side. Little things like that will keep things rolling smoothly. Same 2 steps over here. It's one nice thing with doing it twice. Once you've done it right the first time, You really don't have to think that much about it for the rest. Now, the graphing part. Before I start graphing, now this is not a necessity, but man, does it help. If you can remember the difference between and or statements, that's going to help you know what your graph should look like to know if you've made a boo-boo. How do I remember that? If the absolute value is less than, if the arrow is pointing at the absolute value, that is an and statement. And and statements have our sandwich type look to them in a smaller graph. So, when I go to graph these, the other benefit I have, if I keep my variable on the left side, is that I can kind of arrow follow. We don't like to get in that habit, but just in case. So m is less than or equal to 4. So less than goes left with my bracket, because that's how I show the or equal to part. So less than goes left. And then I come over here and I go, okay, m is greater than, again, the arrow is chomping down on the m, okay, making itself greater than -2. We're going to the right, and what should happen does. My two graphs come together. There's my sandwich graph. And then the interval notation for that, yes, I know it wasn't on your original instructions, but again, I just like to keep you prepared. Interval notation goes left to right on my graph. So I'd start here at the left at -2 and go to the right 4 and have my graph. So there's all the things I could possibly need on this. Okay, that's all I'm going to do on these all the way through. So I go to the next one. Okay, we'll roll through this one a little bit quicker, just because we kind of saw this stuff on the last one. So just copy the first time, flip the arrow, flip the sign on the second. So we're working along here. Everything's going smooth. Now, people will ask, am I always going to get whole numbers? For the most part, yes. If you get a fraction sometime, I would check it for a minute just to make sure I didn't flip a sign or do some other little silly thing. But yeah, occasionally you may have to deal with a decimal or fraction here, and that's okay. So we get here. Okay, now we're back into the same type of situation we were on 3. We're like, okay, what if, big what if here, absolute value is greater than instead of less? Okay, if the arrow's eating that, if the arrow's greater than, that's an or statement. Our graph's going to look like oars of a boat going out to the left and right. At least it should, we hope. X is greater than 8. Greater than goes to the right. X is less than -12. Less than goes left. Again, same symbols. Greater than or less than parentheses, or equal to gets brackets. Hey, they're going out to the ends. This is good. But my interval notation is going to be super big because there's two separate pieces to my graph. So, left to right. Left, arrows are infinities. So forever left until I get to my first point here at -12. And then the U stands for union. That's what we are going to want to say, hey, there's another piece to my answer. Left to forever right. Infinity. Okay, so you see what I mean with the whole really little with and really big with or. That's what we got rolling. One last one of these, and here's what I was talking about up at the top. Before I split this, I need to make sure that my inequality is isolated. So to do that, I need to get rid of this plus this -1. And I'm just going to do it really tiny here so you can see what I'm up to. So that needs to be out of there before I split. Otherwise, half my answer is going to be wrong. I'm just telling you it's going to happen. So once I do that, now it's just like the rest. Copy it the first time, second time, flip your arrow, change your sign. We're good there. And now we're doing the same thing that we've done in the last two. Opposite of my positive 3, we're going to do negative there. Ooh, I see one more thing that's going to be fun. I get here to the end. You're like, what's so big? It's just like divide still. It is. But remember, when we divide by a negative, we've got to flip the arrow. Ooh. Keep these things in mind. Details, people, details. Math is not just about numbers. It's about learning how to look deeply at things and look for details and not make little errors and stuff. That's going to help you in a lot more places than just math. Again, divide by a negative, arrow flip. Is this one an and or an or? Absolute value is less than. It's an and statement, so we know what this should look like. It's hopefully. X is greater than negative 6. Okay. Greater than goes to the right. And X is less than 9. Less than 9. Hey. And then my interval notation. Left to right. Okay. It's the same process. Over, over again. Just so I can see here. Okay. Sketch the graph of the linear inequality. Okay, we want things to be in slope-intercept form. If they're in y equals, I know it's an inequality arrow, but the idea is the same. I can just graph this line. So, negative 2 is my y-intercept. That is my first point on the y-axis. And whenever we see slope, whenever we see the number in front of x, that's always rise over run. So when we have slope, rise over run, up or down, over right or left. So I'm like, okay, so that's negative 2, so that'd be down 2 and right 1. Down 2 and right 1. You're like, how many dots do I have to make? We prefer a minimum of 3, but I prefer actually more so we can be accurate. You're like, well, I ran out of room. So if I'm doing negative 2 over 1, 2 down, 1 right, I also can do the opposite of that if I switch both sides. So I could go 2 up and 1 left. And notice I'm on the same graph. Now, before you go connecting the dots, one more thing to be aware of. You're like, mercy, there's a lot of things to keep track of here. When I'm looking at these, if I have an or equal to, okay, that's going to be a solid line. If I just have less than or greater than, that's going to be dotted. That's how we're going to be able to show that to somebody who just sees the graph part. So here, since it's or equal to, that will be solid. We do that. And we have one step left. One step left because it's an inequality. It's not an equation. We have to do some shading. You're like, okay, so how does that work? Because Hardy, I'm running out of room on the top of my page here to write all these little side notes you're giving me. So shading. If you're visual, okay, if it's greater than or equal to, you're going to shade above the line. We'll talk about what that means here in a second. If it's less than, we're going to shade below the line. Okay, so here's what typically that's going to mean. You can kind of see where this line above it would be. Where are the y values getting greater? Well, if I'm on the y-axis, they're getting greater along here. So I would shade on the side, basically where that up arrow is. Now, if you're not sure sometime, you can use what's called a test point. So how does that work? You can pick a point on your graph anywhere that's not on your line. Whenever I have the option, I love using 0, 0, just because 0 is easy to plug into stuff. But any point would work. 0, 0, I would plug in 0 for y. I would plug in 0 for x. Now, I have to understand my inequalities well enough to know what this is asking. Is 0 greater than, is 0 bigger than -2? Well, yeah, 0 is bigger than any negative. And if it's true, you shade on the side where your test point is. If that wouldn't have been true, I would have known, well, this is all false then. I just shaded on this side. So they both are going to work. You got to figure out which one of those is going to work for you. So that's why we practice. So we know which one's going to work better. Okay. +1. Negative, Hardy. What do I do here? That negative's in front. You get to pick which number the negative's on. You can do -1/3. You can do 1/-3. Just not both. Not both is in putting a negative on both. So down 1, right 3 works. Or up 1 and left 3 works. Line is underneath. Why did I make all the lines underneath? Why didn't I put any that aren't? What the heck? And again, y is less than. Less than is below. I shade here. You're like, yeah, Hardy, still not quite just above, below. Again, if you need to, find that test point. If I use 0, 0, 0 is less than or equal to 1/3 of 0. Is 0 less than or equal to 1? Yeah. It's below the line. Shade. Now, the last two, we have to do a little bit of work because these are not in y equals yet. So, job number 1, we want these in y equals. So, I'm going to -5x. Now, you may wonder, Hardy, why can't you just write 5 minus 5x? That's a legit question. Most of the time we would probably just do that. But remember, we want slope intercept where the x term is first. So I really want to put the x term first here. And that y is not quite alone yet. It's still at a -1. Oh, negative. Negative. Flip your arrow. So there's my inequality. There's my -5. Up 5 and right 1. It's all the dots I can get this time. I can't get more than 3 if I wanted to. It's still or equal to. So now, this time I look, and I'm like, okay, well, it looks more like left and right than above, below. I'll still say like I did before, you can know where the above is by looking where the y values are getting bigger, and that's the side you're going to want to shade on. But again, if there's ever that moment of doubt, we got our favorite test point available. So you can do it here or here. I like to plug it in the one that's actually solved. It's just me, though. 0 minus 5 is -5. Okay. Is 0 less than -5? Now, if you're not sure, make yourself a little number line. There is nothing illegal about giving yourself a little bit of help on things. Here's 0, here's -5. Which one's further to the left? -5 is, that's less. 0 isn't less, -5 is less. This is false. So since this is false, this whole side of my graph where my test point is false. It doesn't work, it's wrong. So I shade on the other half. Okay? Like, oh, Hardy, I don't know sometimes of this stuff. We're almost there. We're almost there. And at least you have got some parts now to be able to work with. And sometimes it is. It's going to be about your willingness to keep working through these and practicing until it makes sense. It may not make sense the first couple of times, but if you keep doing it, using the examples and not just giving up and going, Hardy, I don't get it. Talk me through another one. Sometimes you just got to fight through it. It's true. It can feel harsh, but it's true. Solid line. Y is greater than, we're shading above. This time it's easy to see where above is. So I'm not going to get into the test point this time. We're just going to shade that and see where we're at. I saved the easy part for last. Well, hallelujah, Hardy. It's nice of you to do something nice for us here. All right. Last part, sketch the graph of the line. Slope-intercept form, people. Slope-intercept form. Undo whatever is there. Slope is always a fraction. There is my y-intercept. Down 4. Right 1, because I know you wrote down the directions on the last page when we were there. If not, rewind me back, write them down, then come back. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Okay, no dotted or solid, no shading, it's equals. Okay, that's it, that's it, that's done. I'm telling you, this is doable, people. If you're willing to put the work in, I will give you the tools that you need. The question is always going to be, are you going to use the tools? And only you know that. Okay, now we get a little twist on this one. Ew, fraction. Yeah, it happens. Hardy, I can't go up 10. I agree. But remember, we always have the option of switching the signs of both numbers. Usually it's been one positive, one negative. Well, what if they're both positive? I can make them both negative. I can go 1, 2, 3, 4, 5, 6, 7, 10 down and 1, 2, 3 left. Hardy, I can only make 2 points. Well, that happens sometimes. We don't prefer it that way, but sometimes that's what we got to do. That's what we got to do. And finishing with the easiest of all, they're already in slope intercept. 1, up, right, up, right, up, right. Okay, enough points, Hardy. I gotcha. Because again, if I don't see a number in front of x, we assume it's 1 or 1 over 1. So that's why I was able to go so quickly with and make that work. -4, y-intercept. +4 over 3 slope. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And that, I believe, yep, that's a wrap on this one. So thanks for watching. If you've worked through this and tried a few of your own practice problems from some of the other assignments, and some things still aren't clicking, come show me that stuff. Let's work through some things. But again, take these and do them yourself, and then we'll be good. Have a good one.